Hello my dear students, again you are in physics class and in this lecture we are talking about the rotational motion. Okay. Now in Newton's law of motion, one concept we have covered is the acceleration of two blocks which is connected via a string over a pulley. Okay. If this pulley is massless, this pulley is massless means very negligible mass, and we are connecting two blocks M1 and M2 at the end of a string over this pulley, okay, like that. Now if this M1 is greater than M2, what will happen when this system will release? What will happen? This M1 will move with acceleration A vertically downward. M2 will move with acceleration, same acceleration, because in this case we are taking a string inextensible. So the acceleration of this M1 vertically downward and M2 is vertically upward with same acceleration. Magnitude is same, direction is different, is opposite, sorry. So if M1 is greater than M2, this acceleration A is equal to M1 minus M2 divided by M1 plus M2 into G, okay. And if this pulley is massless, okay, having negligible mass, then the tension in the string at both sides will be same. T1 is equal to T2. But what will happen if this pulley having some moment of inertia, having some mass, having some moment of inertia? So to rotate this pulley, tension of both sides will be different, okay. So what will be the acceleration? Okay, in this case what we have to find acceleration of blocks when this pulley having radius r and moment of inertia is equal to I, and one block M1 and another block M2 connected to the end of this string which is over the pulley, passing over the pulley. Now the tension should be different. If tension will be same, then how we can imagine, how we can consider this pulley will rotate? If we are pulling this, if we are applying same tension to the both end, then how this pulley will rotate? So tension will be different, tension should be different. So let us consider, in this part tension is T1 and in this part tension is T2. At this end and this end, direction of tension will be downward, and at the block it should be vertical upward, same tension, okay. So if this pulley is rotating in clockwise direction, so this tension should be this T1 should be greater than T2, then only this pulley can rotate. This T1 should be greater than T2. So this T1 into perpendicular distance r into this perpendicular distance r providing clockwise torque, but T2 into r is providing anti-clockwise torque. How? This T1 is rotating pulley in clockwise direction, but T2 rotating pulley in opposite direction, in anti-clockwise direction. Still this pulley is rotating in clockwise direction, means this torque of T1 is greater than T2. So, net torque is equal to T1 into R minus T2 into R. Why? We are subtracting because opposite in direction, is equal to I into alpha. Let us consider pulley is rotating with acceleration alpha, angular acceleration alpha. Now if we are using FBD of M1, this M1G vertically downward and T vertically upward, so we can write M1G minus T is equal to M1A. Since acceleration of both these block will be same, because this block is connected to the inextensible string. Okay. Now for M2, what we can write? This block is moving vertically upward, so T2 should be greater than this M2G. T2 should be greater than this M2G. So M2 T2 minus T1 T2 minus M2G is equal to M2A. This is equation number 1. This is equation number 2. It is equation number 3. Okay. And one equation, one relation also is A is equal to alpha into R. The relation between this acceleration, linear acceleration of this point, if this block, this string is moving vertically downward with acceleration A, this point will move vertical downward with acceleration A, and this relation between A, alpha and R we can write like that. So this alpha is equal to A by R. Now we are putting value of alpha, value of T1, value of T2 in this equation, we will get acceleration. So from here T1 is equal to M1A minus M1G minus M1A. What is T2? T2 is equal to M2G plus M2A. Okay, this is T2. Okay, it is not visible. We can write here T2 is equal to M2G plus M2A. Okay, now we are putting all this value in this equation 1. T1 is equal to M1G minus M1A minus T2 M2G plus M2A plus M2A. I am multiplying the negative sign inside the bracket. So is equal to I, and alpha is A by R. Also we have to multiply R here. So finally we are getting what? M1 minus M2 into G is equal to M1 plus M2 plus I by R square into A. So acceleration A is equal to M1 minus M2 into G divided by M1 plus M2 plus I by R square. I by R square. Okay. I think it is very much clear to all of you. Okay. So when this case is totally different. Okay, when pulley having no mass, or mass of pulley is negligible as compared to the M1, M2, then this formula we have to use, acceleration is equal to M1 minus M2 divided by M1 plus M2 into G. But if this pulley having moment of inertia I, having some kind of mass and radius R, then what we have to do? This acceleration A is equal to M1 minus M2 G divided by M1 plus M2 plus I by R square. Very easily we can understand. Okay, so it is the concept of rotational motion. In this case pulley is rotating. Okay, in this case we are considering pulley having some moment of inertia, having some mass, and it is rotating due to the motion of these two blocks. So we can find the acceleration by putting value of A in this equation, and in this equation 2 and 3 we can find T1 and T2 also. Okay, thank you very much.